TSN itself sounds complex, but today I'm going to try to explain how you can understand TSN with a real world example. So this is where I'm going to start with. So imagine there is a meeting room and there are 8 people inside the meeting room and all of them are talking at the same time and all of them have important information, but since they are all talking over one over the other, so there is a lot of chaos in the information as nobody is able to understand and there is too much noise and there is loss of information. So now they have identified that it's a problem, and what they have done is they have decided to choose one person as the master of the meeting, and this guy is asking everyone to make sure that the clock of everybody's watch is at the same time, and then he sends some messages like, hey, now if your time is 37:55, and then he's asking the guys to either come back or go forward and try to adjust to make sure the timing of all the clocks are at the same time. So the master always announces that, hey, my time is right now this, so please adjust your clock accordingly. So now what happens is the timing of the master is equivalent to the timing of all the other participants in the network. So this gives us the facility that now the entire group agrees that, so the person number 0 will talk from the timing 0 to 10 seconds, and person number 1 will talk from 10 to 20 seconds, and so on. So now all the 8 people in this meeting will have a 80 seconds time frame, and each one gets its own slot to talk so that there is no loss of information happening in this kind of a scenario. So this is where we can directly compare with TSN. So you can see initially there were 8 participants in the network and all of them were talking together, and you can see there is a chaos in the traffic and there might be also a lot of loss in data. So let us replace 8 people with 8 traffic classes, and without 802.1 QBV you can see that there is lot of losses, and once you switch on the QBV you can see each one gets their own slot to talk or the own bandwidth allocated. So this gives the facility that the traffics are not lost. So initially, as I said, you can see that they were all in chaos and there was one master who was distributing the time. So this can be directly replaced with 802.1 AS, which is time synchronization protocol, and once they allocated specific slots to talk, this can be said that this is 802.1 QBV. And to explain a complex item which is frame preemption, which can be compared like, so imagine person number 3 is going to talk now, but person number 4 can be assumed as a moderator of the meeting, and he has to interrupt person number 3 while discussing because he has much more important information which might also change the information that number 3 is presenting. So he is able to, without frame preemption, he has to wait with us, although he has to talk at the 10 seconds point of number 3 slot, he has to wait for 15 seconds here, as you are able to see. But with once the frame preemption is included, you can see that the person number 4 is able to interrupt person number 3, and then he's able to get a advantage of 15 seconds of latency in the previous case that you're seeing. So he has to wait for until person number 3 is completed before he starts. But here you can see that he has interrupted, he has spoken, and he has exited, and again person number 3 is able to talk again, and then the entire loop continues. So this can be compared with directly to 802.1 QBU and QBR standards, which is frame preemption. And thank you so much, which is